is there a way to test whether or not it's equivalent to some MAC system? And so what I did was analyze information flow. And so you take each operation, you look to see if it's a reading kind of a thing or a writing thing or maybe both. If it's an update, you have to split it. And then you draw the information flows that result. And the crucial thing here is that when you're assigned a role, you get all the permissions. There's no leeway there. It comes as a unit. And so you end up with a graph that shows where information flows are possible. You collapse cycles because the things in a cycle, they flow to each other, so they're going to end up with the same label if you're going to label things. Now, you don't always get a lattice. Not every acyclic graph is a lattice. Okay? And so if it is a lattice, you're done. If it's not a lattice, well, you can just say this is the information flow, or you can fool around with it a bit and try and turn it into a lattice by collapsing some of the roles together. So, I mean, as a, you could collapse everything to one role, and it's, you know, it would be a lattice, but it wouldn't be very interesting. So, anyhow, so that's, I never really finished that little bit about trying to figure out how to convert it into a lattice when you end up with the information flows that don't happen to be a lattice. So moving on then to simulating DAC. So we have these administrative roles. And what does this actually mean? So this was an original mapping originally that Sandhu and Munawar came up with. So we have the object here with its access mode. And then there's a regular role that contains that privilege. So this is, the blue thing represents a privilege. So you have a regular role that contains the privilege. And then there's an administrative role that allows granting of that privilege. And then there's an ownership role that can grant with grant options, so it can actually create grantors. And so the role hierarchy, then the owner role inherits the granting permissions, the regular permission, and has the owner permissions. And so for every privilege for this version of it, you get 3 roles, which seems like an awful lot of roles to me. So what are some of the extensions we did then to the role graph model? So this example here, we have a role for undergraduate student. And what we would like to do is to assign this group called students to this role here called undergraduate student. Now, the dirty little secret is that what we assign to a role is actually an object access mode pair. It's actually an individual object. And so I guess at Purdue you have at least 40,000 undergraduate students. So you would have to create 40,000 student roles, because each one of them, if they're going to read, if this represents their student record, and you want to represent the fact that students are allowed to look at all of their student records, you would have to have an individual role for each student. So we came up with the idea of parameterized roles. And the idea is that the permissions have parameters which correspond, in this example, to the student ID. And then when a student activates the student role, their student ID is used to only instantiate the role with the privilege that corresponds to their student record. So they get their own version, if you like, of the student role. And so the design of the role graph is very simple, but when it is in use, you get sort of individually tailored role activations. Okay, and so we call this parameterized role. So you can talk about constraints. I mean, there's different ways to model it, but the basic idea comes from here. And it wouldn't help to have some kind of a type system for privileges. I mean, the problem really is that we need some kind of finer grained constraints on role activation. And we'll use that in a minute for something else. So then the other extension we have is dealing with administration of role hierarchies. So the initial role graph model and the ANSI model and the Sandu model all assumed centralized administration. So you have one role administrator, role graph creator, whatever. And so in a very, very large organization, this is not realistic to have one person in charge of the whole thing. And so people have come up with these designs for administrative models. Now this one by Crampton and Loizou is, they have these things called administrative scope, and they have these elegant mathematical properties. The consequence of which is that if you add a role here, X, this thing sort of pops out into a different shape. And so that the roles that this PL1 role controls change sort of on the fly. And so my student, Wang, who's going to finish his PhD in a few weeks, came up with, actually this was his master's thesis, an administrative model which is decentralized. So you can have different administrators looking after different parts of the role hierarchy or the role graph. And the idea of what we call an administrative domain is that the top role in each domain contains all the permissions that any of these roles are allowed to have. And so if you're assigned to the administrative role, so this is the administrator, these roles are administrative roles, and you want to add, say, a sub-role to this US agent here, you can use permissions that are in this part of the graph that you control. Permissions get added into this top role by somebody in a surrounding domain. Now, why do we do that? Because if the administrator here of this distribution domain is allowed to add arbitrary permissions, they get propagated out beyond the region of the graph that he's supposed to be controlling. So,
Sylvia, I have one quick question, which is about the separation of duty constraints.
Right.
So, for example, suppose you want to define a separation of duty between clerk and distribution admin.
Yeah.
Who can define this constraint?
Whoever's administrating a surrounding domain.
Oh,
so
okay.
at the very least, there's always this topmost administrative role.
So he has to do.
Who controls, so max role, so this was the reason for keeping max role, because it kind of is the, we call this the domain ID, it's the top role in the outermost domain.
But couldn't the two local administrators do this operation jointly rather than going up?
Not the way we've defined it. Yeah. But now going back to that example here where this role X appeared sort of off to the side, if a role X was to appear up here, it would have to be done by somebody who controls the domain that it's in. Now, what we do prohibit is if we had because we add edges whenever we find a subset relationship, we might end up with an edge, say, between one of these roles and the accounting role. And the reason why we don't want that is then somebody can add a permission over here, which ends up affecting a part of the graph that they're not under controlling. And so we prohibit, again, things that upset our view of the world. So we would prohibit. But you can have permissions that are replicated, but as soon as the situation is such that an edge is going to pop up there, we're going to reject that operation and go back to the previous version of the graph. Okay. So having this administrative model, and we also have a delegation model, which I won't have much time to talk about today. The question that I posed to He was, what about discretionary access control? Is it really an administrative function, or is it a delegation function? Because if you look at relational databases, all you get to say is grant and revoke. And when you say grant and revoke, are you designing the system ahead of time, or is the system running and you're just delegating something for the afternoon because somebody's sick? Okay, and so which model? So I mean the